Right, so today we're going to go through a little tutorial on JSON Web Tokens. We're going to talk about just the basic Node.JS Web Token package and how you can use it to basically secure your apps. So this is the package we're going to be using. It's called JsonWebToken. So I'm going to make a new project. So I'm just going to call it JWT. I already made it the folder. I'm going to npm init to make a new package.json. Okay, so now I'm going to npm install JsonWebToken, and I'm going to do save, which adds it to the package.json. Oh, that didn't add it. So there we go. So now it's added to the package.json, so now anyone could npm install here. I'm just going to make an index file. That's kind of the default file. And console.log JWT. Okay, so this is just a simple test. Expand the text a little bit. For now, we're just going to run the file. Okay, we run the file and we're logging the JsonWebToken package. So we can see from this that the package contains a couple of functions: decode, verify, sign, JsonWebToken error, not before, blah, blah, blah. So the important things are going to be decoding a token. We can put all sorts of information inside of a token, and then sign, which should create a token. So basically, we're going to have a sign up function. Sorry, we'll call it login function. And this one's going to return a token. And then we're going to have a authorize request function. Make a little user object here. This is my test user. We're going to make users. It's going to be a database that basically it's just going to be an object that as the keys, they are the IDs of the user, and the values are the users themselves. So since we only have one user, Nick, our users array will just have Nick. Now we could do a second user too. Why not? Should probably make these consts because we're not going to change. We're not going to reassign them. Mike. Okay, cool. So we've got our users database. And of course, you'd use a real database in your application. So I'm just logging it, make sure that it is working as intended. Okay. So usually a login function would have a username and a password. We're just going to store password as like test for now. Test 1 and test 2. Okay. So usually you would use some crypto to kind of store an encrypted password hash. And when the user logs in with a password, you would then hash it and check the encrypted one against the database. But since that's out of the scope of this tutorial, we're just going to store a clear text password, which, let me just say, not best practice is ever store clear text passwords. Don't do it. So we're going to log in with Nick and the password test1. And let's run it. Okay, so here we'll delete this. So basically this login function, we're going to search the user's database, and we're going to like see if there's a user that matches the password. Now, since this is keyed by ID, you know, it's only a lookup by ID. That's not really helpful. So we'll make a second lookup table by username. And of course, if you had a real database, you wouldn't need to make these lookup tables. You would just be able to issue a query, get user by name. So this will be Nick user, and then Mike user 2. Okay, so then we're going to implement our login function. We're going to say const logging in user equal users by name, index by username. So this is going to look up the user, and if there isn't one, we're just going to say that there was no logging in user. Now we're going to, now that we have the user, we're going to check that their password matches. So once again, to use encryption to compare only password hash with hash stored in DB. So you could do that as homework if you want. You could learn how to hash passwords. Let's just look up real quick JS password hashing. There's a bcrypt. Yeah, you could use the bcrypt library. Use at your own discretion what a password hashing library. Okay, I guess I'll do a later tutorial on that. So now we're going to check. So if okay, so we're going to check if the logging in user's password is not equal to the current password. If so, we're going to throw. Design decision: when you're building, you know, a function that checks multiple conditions, I like to try to throw or exit the function as soon as I possibly can, and only if it doesn't throw will it actually execute the meat of the function. So the meat of the function is we're going to build a JWT for the user. So basically this means we've you know, we've logged in the user, and we can console log login successful. And since we've logged in the user, we need to supply a token back to the browser that identifies the user by their ID. So basically the browser can have these tokens, and as long as you have this token, it identifies when it goes to the server that the request came from a particular user. And the server is going to call authorize request at a later date, and it's going to validate that that token exists. So that's what we're going to do. So first, let's figure out how to encode the user ID into a token. So we have this JsonWebToken package, and we can just look from the very basic stuff that you could synchronously sign with an algorithm. So we're gonna copy that. Now the synchronous versus asynchronous. You're gonna want to use async on production because you don't want to do pretty much anything cryptographic synchronously. It could bog down your Node program since it only runs in a single thread. So you would you would hopefully have a promise-ified version of this, and I'm sure there is one, but you could just use, you basically want to do the async route. But just for the purpose of this tutorial, we're just talking about how tokens work. So we're going to use our JWT library, which we imported up here, line 1. And we're going to sign, which means we're going to generate a cryptographic token. We're going to do it synchronously, and we're going to put whatever payload we want. So we could actually put the whole user payload into this token. The benefit of that is when it goes to the server, basically you would have all sorts of data about the user, not just their ID. So that's really useful. You could store any type of session data in the token along with the user. It increases the size of the token, so the string will become longer. But honestly, the best thing to do if you want to keep your tokens small is just do the user's ID, and then what you're going to do is you're going to get it from the database later when the user, when you're authenticating the request. You'll get the rest of the user information. And the reason why you want to get the rest of the information later is because user information changes all the time, right? So, like if you're doing a game, the user's like hit points or whatever will be changing all the time. So you basically every time they do a request, you want to check what their you want to check the database, make sure you get the latest user. Okay, so we're just gonna call it user ID, and we are going to we're going to put the .id. And now the second argument is a shared secret. So the shared secret is basically, in order for the cryptography to work, your server has to have a secret that the browser doesn't know, right? So basically it says, you know, if I'm going to be able to do a two-way encode decode, I need to know that there's a secret that only the server has. And so basically if anyone were to get access to these tokens on the browser, they wouldn't be able to decode them because they wouldn't know what the secret is. So we're just going to make a secret. Let's say config.secret. We're just going to call it test because why not? Okay, so we're going to sign it with the secret, and we're going to get a token, and we're going to return that token. Let's try running our program. Okay, so our program gives us this string. So basically the browser issues a login request. It sends the username and the password. We check that. We check the user. We find it in the database by the username or the email. Once we find the user, we check that the password of that user matches. Once again, always storing a hash version of the password. Once we get that user and validate that their password is correct, we build a token that uniquely identifies them in a safe way, and then we send that token back as a response, which goes back to the browser, and the browser gets this, and you would store this probably in local storage or whatever, just to keep it on the browser so that if the user refreshes, the user's JWT token will still be there. And now the browser is going to issue a follow-up request. So I'm actually just going to call this API call. And then we'll pass a request to object. Of course, if you're using Express.js or something like that, the request object kind of comes with the territory, but we're just doing a nice little mock. So this request is going to have a body. And this body would probably be sent in JSON. It's just going to say hello world. It's going to have headers. One of the headers might be Auth token. It's kind of whatever you want. you could pass the token in any header. But Auth token or whatever. So we're going to pass the token that we got from logging in. And the path for this request is going to be /test user is logged in. Okay, so we're gonna hit this API call, passing in a request. Let's try that. Unexpected token. You probably should have caught that. I bet you did. Okay, so usually headers will be an array, but we're just going to do a key value. Easier to look up. Running it. Okay, so we can see a request came in the header Auth token is there. So we are going to extract it. We'd probably make a middleware for this, but we'd say okay, so we can see that we've got the auth token from the request. So now we want to decode the token, which we can look at our documentation. So remember, we used JWT.sign to generate the token, and now we're going to decode the token. I'm going to tell you after this about expirations and why they're important. Okay, so I'm just going to use this example that we got to decode the token. Remember, you only use let if you're going to reassign a variable, so you should really use const if you can. Okay, so we're going to do a try catch here because it'll throw an error if it has trouble decoding the payload. I'm decoding payload. We're just going to log the error and keep throwing. Generally, when you throw, you want to throw like a real error exception object, not just a string. It's bad practice. Do as I say, not as I do. Okay, you see here this second argument, it says wrong secret. So this is, once again, that JWT secret. These need to be shared. One of the beautiful parts about JWT is that as long as your servers have the same secret, you could actually have 10 servers that listen to the same JWT tokens and can decode them. So if you were doing microservices in languages like Go or whatever, you could actually basically theoretically use the same auth token and decode it using a different library as long as you're decoding it with the same algorithm. So JWT is pretty superior to sessions for a lot of things. Sessions we could talk about later, but basically they need to be stored in some kind of data store, so they're not really as scalable as JWT is. You can see here that we're calling JWT.verify. That's actually not what we want to call. We want to call, is it? I think it is. Okay, so I was wrong. So verify is actually basically the decode function. So no problem. We're just going to call verify. We're going to get a decoded payload. let's see what's going on now. Okay, so we decode the payload, and remember we had signed it with the user ID up here. So now basically when we decode it, we get a user ID, so that's awesome. So now that we know that that's what we want, we can actually just do destructuring to pull the user ID out of that object. It's just a nice thing to be able to do. Now we're going to look up the user in the database. As you remember earlier, we had this users database, which is just a hash map by ID. So since we have the user ID, we can easily look up the user. And then if there is no user, we're going to say no user. So even though the token did validate and verify, if there's no actual user with that ID, there's nothing we can do. Else, we can actually return the user. So we're going to assign the user to whatever is the result of API call. User successfully authenticated. Right. Okay, we're going to say logged in user. Okay, so basically if we start from the top, we see that we called, let's just take a look. We called login. We passed a valid user and password. Let's use an invalid password. We'll just say test. What happens? Okay, so it just throws an error, invalid password. So if we do a valid password, then the login function is going to give us a token. We then put that token in a header in our next request, and we're basically just hitting a path that just checks if the user is logged in. Right here, we're going to do another call, so we're going to actually send the request. So we send the request. It decodes the user. It looks the user up in the database, and then returns the user via JSON. And now we have a user. So you could now do anything that requires a user, requires a authenticated user. So basically any sort of API call in your application. Just to talk about expirations. So in the olden days, when people were building tokens, what they would do is they would generate just like some random hash, and then they would store it in a database somewhere, and they would put an expiration date on it. So you could imagine if you have 300,000 users, you might have 300,000 tokens in some database somewhere. So obviously that sucks because that means we have to put these tokens in a database or whatever, and it's just annoying to look them up by that. But we did it because it was really nice to be able to have an expiration date. So one of the cool things about JWT is they have expiration dates. So in our current one, I think it's an infinite expiration by default, but we could just as easily configure it to expire. So we can see that one of the options is expires in. So when we're doing sign, we can actually pass options as a third argument. So let's try that. I believe that's how they want it. Options is not allowed in options. So it's really just this. So, okay, so here's a token that expires in 60 seconds. And basically, if I waited 60 seconds to do this next call, it wouldn't work. So yeah, that's basically a story of how JWT works.